Just really quick, we're going to take a look at the last two sloped cut questions on page 18. So one of them we don't need to find a point, the other one we do, but again, look, it'll just be there for you to look back on if you need, and it'll be there for a bit of help tonight if you need it. So again, get this sheet done tonight if you can, and then get the second sheet done tomorrow. I'll have a video up on that as well that you'll be able to use to help you through class as you go, okay? And even if you want, what one of you can do is log in on my computer and throw it up on the big screen either if you want. Now that I know you'll all probably be at different stages and stuff, so that mightn't help, but just a suggestion. So we'll zoom in if we can. Now forgive me here because this visualizer actually won't zoom in. I'm going to have to manually zoom it in a bit. So the angle is going to be a bit wonky here. Forgive me, it's actually incredibly wonky. Forgive me for that. We'll try and move it a bit without having the wires draped across my page too much. Right, so the map shows ground contours at 5 meter vertical intervals. Again, straight away, I'm going to underline that. The proposed roadway falls from x to y at a continuous gradient. Grand. So continuous gradient means that there's no slope ratio. A and B are on the centre line of the road of altitudes 85 and 75. Lovely, underline that as well. Using side slopes of 1 and 2 for the cuttings. Again, underline in red. 1 and 2 for the cuttings. Complete the earthworks necessary to accommodate the roadway. So straight away, I'm going to write in A is at 85 and B is at 75. Okay, so next thing we do then is we're going to calculate our cone. So that is 85 take 75, which is equal to 10. The ratio we're given is 1:2. So multiply by 2, which equals 20. So 20 or, that stands for 20 radius for our cone. Out comes the compass. And again, think of the saying, fill to the top. So fill cone is at the top, cut to the bottom. So our cut cone is always at the lower height. Make sure as well that B comes all the way out to the edge of our road for us to swing it. So cut cone from the lower height. On goes our compass, swing it around. Lovely. There is our cut cone. First line then comes from A. And we will draw tangential to the cone or to the circle. Whatever you want to call them. Lovely, so off he pops like that. Again, it's important to remember that that line is at 85. So again, to calculate then the gaps for the contours, we're told 5 meter vertical intervals, ratio is 1:2. So I call these gaps, so our contour gaps. So that is 5 multiplied by 2, which is equal to 10. Okay. And again, you can draw in your little triangle if you want, but I never actually found them much use, but maybe some of you find them a great assistance. So I'm going to look here. I have 85. It goes all the way down to 1870, and it goes all the way up to 120 actually, which is quite high. So 85, 90, 95, 100, 110, 120, and then for 80 and 75, we come to this side of the road, 80 and 75. Lovely stuff. Where is my other set square? There you are. So now all we're going to do is what we've done the whole time. We're going to bring these up parallel, just like that, all the way. Nice and straightforward. So we'll start by marking 85, 90, 95, 100, 105. Oh, am I short a line? I'm short many lines. How did I manage that? I must have skipped numbers drastically. 85, 90, 95, 100, 105, 110, 115 and 120. Apologies. I tend to do that very often, actually, funnily enough. I count out loud and somehow miscount. Now, saying that, are they going to be on the page? That's interesting. Just about. 120 will literally just be cresting the edge of the page there. 115, there's 110, and then we have our two 1875 that are just below. There's 80, and there is 75. Well, we even have a 70 and a 65, but again, I wouldn't worry too much about that because in an actual question they would have to be cuts. But anyway, there would be our 70 roughly. So this comes all the way down there like that, and all the way down to about there. Okay, so that is the first question covered. The last thing then to remember is just our tadpoles. So our tadpoles always swim upstream. And I think it was Sammy was saying it, or Molly maybe, they like to remember it as, for the cuts, they swim away from the road, and for the fills, they swim towards it. So whatever way you want to remember it, you remember it that way. So that's question 1 done. We go on to the final question then. So straight away, we come down here and start underlining it. So the map shows ground contours at 10 metre vertical intervals. Lovely. The proposed roadway falls at a rate of 1 in 10. Lovely. That's a nice even number to get. So again, that's just saying if I walk out 10 metres, I'm going to lose a height of 1 metre because it's falling instead of rising, okay? Point A is on the central line of the proposed roadway and has an altitude of 90. Lovely. Point A is at 90, and I'll come up straight here and write 90 metres there. Using side slopes of 1 is 1. Absolutely lovely for the cutting. Complete the earthwork necessary to accommodate the roadway. Absolutely beautiful. So let's have a look at our calculation again here for the rising and falling, okay? So I'm going to do this in pink pen up the top. So rising obviously means that we're going up the way, and falling means that we're going down the way, okay? That's fairly self-explanatory, I would hope. So A is at 90, so the road is falling. So we're going to be decreasing in height as we go down the road because it's falling, okay? So we're given 1 in 10, and notice the difference, 1 in 10 versus, oh no, it says 1 in 1 as well, sorry. But usually I'd be thinking of our ratio this way as 1:1. Okay. Anyway, it doesn't matter. So we're given 1 in 10. So again, what does that mean? What that means is that if I walk 10 meters this way, I have lost a meter. Okay. So a better way maybe of drawing that would be like this. So I walk 10 meters this way. God damn it, my lights are going again. 2 seconds. Hello. Thank you. So I've walked out 10 meters and I've lost a height of a meter. So say here was point A and here was point B. Point A was at 90 because if I lost a meter in height, I'm now at 89. Okay, so I hope that kind of makes sense to everybody. Again, we'll go through that again on Friday just to make sure we understand it, and I'll do another video if you don't, okay? So, again, by a rule, we like to measure by 5 or 10, or not measure, sorry, but multiply the ratio by 5 or 10. Now, if I was to multiply by 10 here, it'd be 100, which actually probably should fit on the page. So if I multiply by 10, basically what I'd be doing is saying, I've started at A, I've come down 10 because the ratio is 1:10, and I've come out 100. Okay? So now point B will be at a height of 80. Alright? So A is at 90. We walk out our 100 meters, which gives us point B. And point B will be at a height of 80. Okay? So other than that then, the workings are the exact same. I don't have a lot of space left to do it, but our ratio is 1:1. The gap is 10. So for our cone, again, the gap is 10 between 90 and 80. Multiplied by our ratio, which is 1, which gives us a radius of 10 for the cone. Again, fill to the top, cut to the bottom. So again, our cut cone is going to be from the lower height. So our cut cone will be down here. And again, we're going to have to do it on both sides of the road here. There's one side. And again, remember, swing from the edge of the road. Oop, I knew that was going to happen. Lovely. Bring 90 out to the edge of the road. And up it goes. Same over this side. So for the gaps then, gaps in the contours are 10. Tells us in the question. 10 ratio is 1. 10 multiplied by 1 equals 10. So there's a lot of calculations there. Do your very best, lads, to remember that because it is very important. But I promise it kind of becomes like second nature after a while. So again, this line here is at a height of 90. So what we're going to have to do now is we are going to have to step out multiple times. So how high up do we go? We go up to 120. So we have 90, 100, 110, 120. And how low do we go? Down to 70. Will we cross 70 here? We'll probably get close. So we'll go down anyway. So we have 70. 80 I should say. And then I don't think 70 will cross, but we'll mark it anyway. Just there like that, nice and light. So again, we'll do one side at a time. So before I bring 70 back, I'm going to bring 80 all the way back. So 80 is just about on the page. 70 then is going to be in the middle of the road. So instead of bringing the line all the way back here, because I don't want anything on this side of the page except the workings for that side of the page, we'll just bring it back like that. Rest, and then again, we'll bring all the way through. And again, I meant to say in the last question, I like to start from 90 because generally either side of it is going to either be 100 or 110. Okay. So where is 90? Sorry. So here's 90. So we'll mark off 90. So over here straight away we have 80. Lovely, there's 80. Again, I know that's on the road, but is what it is. Same here, like 80 is right about there. So back, so we have 80, 90, and see it always kind of goes to 100, and then it'll either be 100 or 110, 120, down to 110, down back to 100. Then do you know what I mean? Like it'll always kind of be uniform like that. Like it'll kind of be up and then down. So that's why I like to start from 90. Just very easy. Up we go then. Well, I say I start from 90 because that's where my line is. Do you know? Because that's where this line is. We have to start from 90, and then I know it's going to be either side is what I'm trying to say. I don't know if that's making sense. Hopefully it is. So there's that side of things. Do the other side of the road now. Should I make the measurements first? Sorry. So again, we're at 90, 100, 110, 120, and then one down for 80. I think we are going to hit 70 here. There's a good chance of us hitting the 70 here, so we'll mark that off as well. Again, doesn't matter where you mark these divisions, just make sure that you can see them yourself. And again, you don't have to mark the lines all the way along like this. I know I see crads all the time. We'll take the 90 line here, and she'll find 90 and then mark off a little point. You can do that as well, that's no problem. So whatever way you prefer it. So there's 90, and there is, where's our 80 gone? I didn't mark it in, sure. Why would I? There's our 80. So what I was saying that Neve does, and I'll show you here, just I'm sure somebody else is doing it as well, but just I've only seen Neve doing it. Instead of drawing the line all the way out, she'll just make a little mark at 80 like this to let us know that that line is there, okay? And the 70 line is not going to be on the page. It's going to be down there somewhere, so we'll just do that like that. So there's 90, there's 100, 110, 120, down to 110, back down to 100, and there is our 80 marked then. So then this will just join up like this. Ooh, sorry, that's my bad. They should be connected. Down it goes, just like that, okay? So there we go, lads. That's fairly easy. And again, icing on the cake there is make sure our tadpoles are going the right way. And again, I always like to do my tadpoles in red and green because obviously it tells the examiner straight away where my cuts are and where my fills are, okay? And if you're right, it makes, it's a confident move if you're right. So that's that video done. I'll upload another video now in the questions that I want you to do in class, but hopefully this should help you to finish tonight.